All right, so here's the proofs section of the test review. For 12, 13, and 14, we're proving these using X, Y, and R. So make sure you show all your steps, show them neatly for full credits. So number 12, you need to know the Pythagorean identities for this. I know you're trying to prove the Pythagorean identity. So we know sine squared is equivalent to y squared over r squared, while cosine squared is x squared over r squared. Here we're adding the two fractions, so we can't cancel anything until we simplify into one fraction, which we can do pretty quickly because there's a common denominator of r squared. The Pythagorean theorem, we know that y squared plus x squared is equivalent to r squared. So we're left with r squared divided by r squared. Anything divided by itself is 1. That's our proof. So on to 13. Number 13 is 1 plus, let's convert tangent squared to y squared over x squared. And let's go ahead and convert secant squared to r squared over x squared. The only thing we can really simplify is the left side here. We have two fractions. So what I'm going to do is I'm going to make 1 into a fraction by writing it as 1 over 1. Our common denominator, we're just going to multiply the two denominators to get that common denominator of 1x squared. This side has to be multiplied by the common denominator. So the top left becomes x squared. The top right, we did not have to change. And then once again, we know the Pythagorean identity, x squared plus y squared, is equivalent to r squared. Again, if you have to do a whole lot of work for the problems, try to do it outside of the proof if you can. That way you keep your proofs neat and easier to check for full credit. And the last one of these, number 14. So let's convert cotangent. Cotangent, of course, is x divided by y. And we need to convert cosine. That one everybody knows is x over r. While sine is y divided by r. And then the right side, we can multiply the top, x over r, by the reciprocal of the bottom. So we're just going to flip the bottom fraction. And you should notice the r's will cancel out. So now the right side and the left side are equivalent. That's our answer. 15 and 16, we're verifying these proofs using real angle measures. So number 15, they're letting theta equals 45 degrees. You have to think back to the first chapter, or sorry, the last chapter. If 45 degrees is the given angle, it means it's the reference angle drawn right here. And of course, the other angle in this case would have to be a 45-degree angle. So this right triangle follows the pattern of 1, 1, radical 2. X is 1, because that's your horizontal. Y is 1, that's your vertical. And R is radical 2. So we're going to do this proof pretty similar to the previous 3 problems, except instead of x, y's, and r's, we're going to substitute these numbers for x, y, and r in these problems. So that means 1 plus cotangent squared actually becomes 1 plus cotangent squared, of course, is x squared over y squared. So in this case, it's just going to be 1 over 1. I'm just going to put the squared actually on the outside of the parenthesis. Cosecant squared is, of course, r squared over y squared. So in this case, it's going to be the square root of 2 divided by 1. And again, all of that gets squared. So we simplify the left side. 1 plus 1 squared is just 2. Simplify the right side. If you struggle simplifying this in your head, just put that in the calculator exactly like it looks. That side should also give you 2. Proof is done. We've shown the left side and the right side are equivalent. Number 16, similar, except this time the angle they give us is 30 degrees. So our reference angle's changed in this problem to 30. So it goes in the bottom left corner. And of course that makes this other angle 60. This follows the pattern of 1, radical 3, 2. Y is 1, x is radical 3, r is 2. So substitute those 3 numbers into these trig function formulas. So first the left side, the tangent of 30 degrees. Really, that's what we're doing. We're taking the tangent of 30 degrees. And of course, tangent is y over x. So the tangent of 30 degrees just becomes 1 divided by radical 3. And then on the right side, again, all we're really doing is doing the sine of 30 degrees divided by the cosine of 30 degrees. The sine of 30 degrees is y divided by r, which in this case is 1/2. So the top part of the fraction becomes 1/2. The bottom part is cosine, so that's x over r, radical 3 divided by 2. Simplify the right side by taking the top part, 1/2, and then multiplying it by the reciprocal of the bottom. The 2's cancel. We're left with 1 over radical 3 on both sides. Now, if you get rid of the radical at the bottom, that's fine. Really, we're just trying to prove the left side and the right side are equivalent. So we can stop there. You could have gone an extra step and gotten rid of the radical at the bottom on both those fractions. All right, final type of proofs. These are proofs where we're not using x, y, and r. So you cannot use x, y, and r at all for these proofs. Instead, you need to memorize those sine and cosine trig identities we talked about. Those all have to be memorized. So the trick to these is change everything to sines and cosines. So for instance, secant, we know, is the reciprocal of cosine. So secant times cosine becomes 1 divided by cosine times cosine. We're multiplying fractions. Remember, you don't need a common denominator when you multiply. Here we can just cross out diagonally common terms, and we're left with 1 on the left side, and that's what we were trying to get that we already had on the right side. So number 17, that's it. Not a whole lot of work to show. 18, 1 divided by tangents becomes 1 divided by sine over cosine. Again, because tangent is equivalent to sine divided by cosine. On the right side, cosine times cosecant is the same thing as cosine times 1 divided by sine. I'll put cosine over 1 to make that a little bit easier. And then again, on the right side, multiply fractions. You do not need a common denominator, so we're just going to multiply the tops. Cosine times 1 is cosine. 1 times sine is sine. So that's the right side. And now on the left side, all we need to do is multiply by the reciprocal. So take the top part of the fraction, which is 1. If you want to write it as 1 over 1, you can. And just multiply it by the reciprocal of the bottom. Anything times 1 is itself. So once again, we prove the left side. Proving this because the left side and the right side are equivalent. All right, last few problems, 19 and 20. So number 19, So 19, remember 1 minus cosine squared, that's one of our Pythagorean identities. That's equivalent to sine squared. The bottom, cosine squared plus sine squared, is another Pythagorean identity, and that's just 1. Anything divided by 1 is just itself. So the left side simplifies pretty quickly to sine squared. The right side, we can change tangent squared to sine squared over cosine squared. One divided by secant squared, a couple different ways you can do this. One way is if you change secant squared to terms of cosine, it would be 1 divided by 1 over cosine squared. It's possible you could have done that a quicker way. But now this can be simplified by taking the top and multiplying it by the reciprocal of the bottom. Anything times 1 is itself. Now I'm going to bring this down here. Again, we're multiplying, so we don't need a common denominator. So the cosine squareds quickly cancel out, and we're done with our proof. The right side and the left side are equivalent. All right, and then number 20, nothing to do to the right side, so this is all left side that we need to manipulate a little bit. So let's start with the top. So secant is 1 divided by sine. On the bottom, you've got a sine squared plus cosine squared. They're written out of order, but it doesn't really matter what order you add things in. So sine squared plus cosine squared are equivalent to 1. And of course, cotangent squared is cosine squared over sine squared. So again, our ultimate goal here is to multiply the top, which is 1 divided by sine, by the reciprocal of the bottom. But before we can do that, we need to combine these two fractions into one fraction. So I'm actually going to take this outside of the problem. I encourage you to do so as well, so it doesn't get messy. If you need to show work for it, you can do it on the outside of the proof, wherever you have blank space. So again, our common denominator here is sine squared, because you're just looking at the two denominators and multiplying them together. So that's our common denominator. The left side has to be multiplied by sine squared, because it does not already have that as a common denominator. The right side already has that common denominator, so we don't have to do anything to the right side. So now we've combined those two fractions into one fraction with one common denominator. And then we can go ahead and simplify this one step further before we go back to the proof. Sine squared plus cosine squared is 1. So this becomes 1 divided by sine squared. So rewrite this becomes, the top is still 1 divided by sine. Now we're going to multiply by the reciprocal. Remember, this has just replaced the 1 plus cosine squared over sine squared. So we're going to multiply the top by the reciprocal of 1 over sine squared. And now you should see the sides cancel, but not completely, because there's only a single sign in the bottom left corner, and there's a sine squared in the top right corner. So we're left this side of that's on the left, which is good, because that's what we have on the right. The proof is finished. All right, last two, 23 and 24. All right, so 23, I've already done the first step because we know that 1 minus sine squared by the Pythagorean identity is equivalent to cosine squared. It's just one of those things you got to memorize for the test. So the left side is all but simplified here. So now let's simplify secant squared minus 1. Secant squared is the same thing as 1 over cosine squared minus 1. So here, once again, we're not multiplying, so we can't just start canceling things out. You have to get a common denominator. Our common denominator here should be cosine squared, which means you only need to multiply the right side by cosine squared. I'm trying to say c squared here. So now the top becomes 1 minus cosine squared. 1 minus cosine squared, that's equivalent to sine squared over cosine squared. And that completes our proof. All right, then the last one, number 24. Change everything to cosines and sines. Secant just turns into 1 divided by cosine. It's going to get multiplied by the cosine that's already there. You do not need a common denominator. Everything cancels, so we're just left with 1 on the left side. And on the right side, tangent is sine over cosine. We're going to multiply that by cotangent, which is cosine on the side. And then once again, everything cancels. Cosines are gone, sines are gone, so you're left with 1 on both sides.